All right, so hello again. I've got 15 minutes on each segment here, so I'll pick up where I left off on video 1. We're on number 16. This is simplifying radicals from unit or module 6, 5. 5 was exponents. I think it's 5. So anyway, I'm going to find the largest perfect square factor of 60, which is 4. And 4 times 15 is 60. And then for the exponents, I need to find the largest even number, because that's a perfect square. And that would be left with x to the first. So x to the 6th, x to the first from properties of exponents, which was mod 5. All right, now any one that is a perfect square could be square rooted. So I'm going to cross off that because I have the square root of 4 is 2. And the square root of x to the 6th is x to the 3rd, because square roots, you cut them in half. Properties of exponents, and then I'll put what's left in green back under the little radical. I still have 15 and x, and then I'll go over here and circle the correct answer, simplifying radicals. And that was the last of the multiple choices. Now, short answers, you do have to show work. Remember, the directions are listed on Brightspace. And this, I'm going to draw myself a picture. I'm trying to use my straight line tool. And it says that I have a 16-foot ladder leaning against a tree. So what I just drew there will be my tree, and this will be my ladder. And I'm going to make it into a right triangle, because I'm pretty sure it's going to be a Pythagorean theorem problem. Put my little right angle there, right triangle. And it says there's a 16-foot ladder leaning against a tree. So this will be the tree. The bottom of the ladder is on the ground, so that it is a distance of 7 feet from the base of the tree, right? This is definitely not drawn to scale. What is the distance in feet between the ground and the top of the ladder? So I'm going to put a variable right here. We're looking for the distance in feet from the ground to the top of the ladder. So we're looking for that, right? I'm just going to reread it, make sure it's all right. So 16-foot ladder is leaning against a tree. So I guess they're kind of saying like the tree is bigger, right? And the ladder, they just want to know the distance in feet from the ground to the top of the ladder. So that would be the altitude there. All right, so I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. And then I'm going to put in either x or 7, it doesn't make a difference. That's a and b. The quantity or the value that is opposite the right angle, which is called the hypotenuse, has to go in for c squared. And you're going to want to do the math here. So I have x squared plus 49 equals 256. I'm going to do the algebra. And it's going to give me x squared equals, I'm using my calculator, you can hear it in the background, I'm being lazy. So if x squared is equal to 207, then I need to square root both sides, right? So x squared is equal to the square root of 207, all right? And that means, well, I don't have my graphing calculator, I'm using my cell phone. Square root of 207, I think I got it, right, is about 14.38. Right, I'm just going to do that real quick. Yeah, that's about right. But now let me go back and read the directions, because I think it said nearest tenth, so that means I need to look here, right? And that tells me I got to round up, so my answer is going to be about 14.4. And the unit of measure is in feet because the question was in feet. All right, so that's a little Pythagorean theorem question. Definitely something you're going to have to do. You probably will. I don't know if the picture is going to be drawn for you or not. All right, on to number 18. Solve compound inequality. The word says and. So I have to consider what's going to fit into both. It's all going to be determined based on what I get here. So I'd use the distributive property. I'm going to solve each individual inequality one at a time. I'm now going to add 32. I'm going to get 12x is less than or equal to, oh, what's this going to give me? 12. And then divide by 12. So I'm looking for a number that is, I'm just going to work in a column here, less than or equal to 1, and I'll put the word and there so I don't forget. And then I have to solve the other inequality. I think I'll do this one in green. All right, so I'm thinking I'm going to subtract 1. I'm going to get 6x less than 7x plus 39. And then I'm going to subtract 7x. That's going to give me negative x is less than 39. And then I have to divide by negative 1, which means I'm going to have to flip the sign. And we've got that. So we're looking for all the numbers that are greater than negative 39, but also less than 1. I'm thinking to myself, hold on a second here. We've got less than 1. Here, I'm going to put a 1 here. I'm not drawing it to scale. Okay, so we want all the numbers that are less than or equal to 1. So that's going to be everything that I'm shading in blue. And then we also want everything greater than negative 39. So the answer is everything from negative infinity. Oh no, sorry. Ooh, I made a mistake. Let's cancel this. I made a mistake because it's and, it's not or. It's only where the overlap is. I'm not going to cancel it. I'm going to own up to my mistake. What numbers are where they overlap? Right? It's all the stuff in here. So it's only the numbers that are less than or equal to 1, but also greater than negative 39. So my solution, oops, let me get the pen that works right. I was going to write solution is going to be in interval notation greater than negative 39 and less than or equal to 1. Good thing I fixed that. There's the answer there, right? Only where the overlap. If it was or, it would have been all real numbers. I'm glad I double-checked that. All right, number 19. State the excluded values. All right, so the excluded values are the values that are going to make the fraction undefined. And that means anything in the bottom that makes the bottom, which is called the denominator, equal to 0. And when I set the denominator equal to 0, I get a quadratic. And the way that I solve quadratic equations is by factoring. So I'm going to look for factors of 15. It's a negative 15, so I need 1 plus and 1 minus that have a difference of 2. So it's going to be positive 5 minus 3. And then I tee them off. I set them both equal to 0. And those are the excluded values. When I set both of these equal to 0, I get negative 5 and positive 3. Those are my excluded values. That's solving a quadratic. When they are asking for the domain, it means what we're allowed to put in for x. So these are the values that we are not allowed to put in, which is why they're called the excluded values. All right, simplify. To simplify this, I'm going to need to factor. So I have to factor the top, factor the bottom. Now the bottom is the difference of perfect squares. That's one of our special factoring patterns. I'm doing the square root. These are called conjugate pairs. You should have watched that in the video when you were learning to factor. And then the top, I have to reverse FOIL. I'm guessing, this is a guess. I should probably put it over here. I'm guessing that it's 3x times 1x. It could be 9x times 1x. But usually when they ask you to simplify, something's going to match down here. So I'm just going to guess. Okay, this is an educated guess, but I'm going to guess. I'm going to show you why those are the factors at the top. I'm just going to write it over here messy. And I'm going to FOIL it. First, outer, inner, last, right? And wouldn't that combine to give me the 12x there? So those are the factors, right? And I had a feeling that since it asked to simplify, something was going to match, because when we want to simplify, we have to divide like factors. So I was going to change the color of this. So I'm going to divide off. Anything divided by itself is equal to 1. And my answer should be 3x plus 2 over 3x minus 2. And I can't do anything else. We can only divide factors. We learned that in modular 8. All right, the length of rectangle. Let me just grab this little rectangle tool. There we go. I'm not drawing to scale. The length of the rectangle is 5 inches longer than its width. So I'm going to make one x and the other one x plus 5. Now this is a question about area, and the area formula is length times width, or base times height. So I'm going to take the length and the width. I'm going to multiply them using the distributive property, and I'm going to set them equal to the area. And this is going to give me a quadratic equation. This is going to give me x squared plus 5x. And then I need to solve a quadratic by getting everything on one side of the equation, set equal to 0. And now I need to find factors of 126 that have a difference of 5. So 126 is divisible by 6, right? That's not going to do it because it's 6 and 21, so that's not big enough. How about 9 and 14? Ooh, yep. I had to think about it a little bit. All right, so I know that I need one positive and one negative. I need them multiplied to 26. So I know that 14 times 9 is 126. And positive 14 minus 9 is positive 5. So these are my two expressions. Those are my two that I can set equal to 0. I didn't show this work on the last one. I kind of whipped through it. You can show it. You can skip it if you want, but you need to get the values of x. So I have negative 14 and 9 are both solutions to this quadratic. However, when we're talking about dimensions, I can't have a negative dimension. So I have to use the 9. And that's what x is going to be. And I asked for the dimensions of the triangle. So 9 and 14, because it's 9 plus 5, right? I can show you that, 9 plus 5. So there's the other dimension. And do a quick check. Is 9 times 14 going to work? Sure it is, right? Because we have 126 inches squared. There you go. So 9 and 14 are my dimensions. 1, 2. All right, I have about 3 minutes left. So I think I'm going to pause. I'm going to upload this video, and then I'm going to finish this off later. All right, so I don't want to rush this. Remember, you can pause and fast forward and rewind and watch it as many times as you want. All right,